In this video, we're going to be working on the University of Waterloo's Canadian Computing Competition Junior 4 2021 problem. So in this problem, basically, to put it quickly, they're going to give you a string. The string is going to be comprised of L's, M's, or S's. Sometimes there won't be any M's. And basically the L's, M's, and S's represent the size of a book on a shelf, right? So for instance, like in this example, LMMS means that there's a large book, then followed by 3 medium books, and then a small book. The second one, LLSLM, means that there's 2 large books, then a small book, then a large book, then a medium book. Now, what the question's asking you is going to say, if I wanted to switch these two, I wanted to put these in order so all the L's are on the left side and all the S's are on the right side and all the M's are in between those. What are the fewest number of swaps that I can do in order to make this happen? Now, in order to swap it, though, you're only allowed to exchange the places of 2 of the books at any time, right? And so one of the problems is that if you actually start trying to swap books, right, then you're going to waste a lot of processor time. And actually, when you see the explanation of the problem or the solution, you'll see that it's actually really unnecessary to actually do any swapping. You can actually just do the calculation if you reason it out. So let's go to the board here and paint, and then I'll explain my solution. All right, so let's say, for instance, they give you a string like so. Okay, and okay, it's big enough here. Let's go like LLL. Let's put a space in between them. So LL. It doesn't actually matter. SS, MML, LS, MLSM, something like that. All right, so now what we can do is we can actually look at this and say, well, first of all, how many total books are there? Okay, so we're going to say total books. Okay, and we can see how many total books there are just by counting them, but I think it's actually will be given to you as a parameter in the problem. So let me just shut this down here. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so I've got 14 books total. All right, so what I need to do next is count how many L's I have, and I believe I have 6. Okay, so what I can do is I can say that this section here, okay, the 1, 2, 3, 4, 5, 6, so the first 6 items in the in the list should be L's, but they're not L's. Okay, and then how many M's do I have? Well, there's 4, right? So, oops. Okay, so let's actually just undo that. Okay, so there's 6, so these L's, this section here should be 6. And I just did it again. Okay, whatever. Let's just hand draw this. Okay, so these 6 should be L's. Okay, the next 4 should be M's. Okay, and then the last 4 should be S's. Okay, like that. All right, now because they're not in this order, we got to put it back into order. Now, what we can see though, or what you should be able to see, is that the shortest way to do this would be to do direct swapping. All right, so ideally what I would do is I would say, okay, well, let's look. If I have an L over here and an S over here, I could swap them, right? So if I swap this S with this L, that would be one swap and it would put them in the correct order. So an L here and an S here. All right, and then what I can do is I can say, well, I have an S here, but no more L's, so I can't do any swapping here. Now I have an M here, and I do have an L, so I can do another direct swap like this, okay, which would replace this with an L and this with not an S, but an M. Okay, like that. And so that's the most I can do in direct swapping from here. Now, if I go to the middle section, the first one's an M, so that's okay. The second one would be an M again. Now I've got an L, but I don't have an M over here to swap with because I already checked that. All right, but I have an S and there's an M over here, so I can actually swap these two, right? And this would become an S and this would become an M, and that's another swap. So as you can see, our total swaps was equal to 3. All right, so S is equal to 3. That looks terrible. S equals 3. Okay, now what would be left though? Okay, so let's actually just undo this. So, all right, so what we can do is we can take away the pairs, right? So there's an L here. So let's consider this. Take out the ones, or don't even think about the ones that are in order. Okay, so L, these are correct. Don't really care about these. Okay, this M, don't really care about this one. This S, don't care about that, all right, because they're in the correct order. All right, now I could swap this S with this L and they would be in the correct order. So let's take those away, and that represents one swap. Okay, I could swap this M with this L, and that would represent one swap that I can do. And I can take away this M, or and actually this S, right, with this M, okay, and that would be one more swap. All right, now at the end, all you're going to be left with is sets like this, okay? And what I refer to this is as a triplet. Okay, so you have a triplet here, and if you ever have a triplet, then it requires 2 swaps to get them into the right order. So what I got to do is I got to move the L swap the L with the S. The L would go into the right order, and then I need an S to swap with the M, and then that would be in the right order. So if you get a triplet like this, then you need to then you need 2 swaps to get rid of those 3. Anyway, so that's what we're going to do is we're going to see how many direct swaps we can do, and then at the end how many triplets we have remaining, and then we can actually just figure it out. Okay, so let's go to the code. All right, so let's take a look here, and the first thing we're going to do is we're going to get our string. Okay, so we're going to say so string, let's say books, or letters, I guess. Letters is equal to just blank, and then we're going to say C in letters. Okay, so there's our letters. Now, the first thing we're going to have to do is we have to count how many L's, M's, and S's we have. But we actually don't need to count one of them. For me, I just counted the L's and the M's because we'll know the array size, or the size of the string, and then we can calculate the size of the small ones, or the number of small ones, if we know how many larges and mediums we have. All right, so the first one I'm going to do is I'm going to make some variables. So I'm going to say L count is equal to 0, and M count also equal to 0. Okay, so I've got my string. Now, just as a for testing purposes, what I'm going to do is I'm just going to go like this: LSM, 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 LSM. All right, so, and then we'll just go like LLM. All right, so this should give 1, 2, 3, 4, 5, 6. So there should be 6 times L. And then we should have, let's see, 1, 2, 3, 4 times S, just for testing purposes. Okay, and then 1, 2, 3, 4, 5 times M. All right, this is just test code. It'll just make things easier as I'm working with the code here. Okay, so the first thing we're going to do is count how many L's, how many M's we have. And then if we need to, and we can count the S's later, but I don't think we'll need to. Okay, so we say for int x equals 0, x is less than letters dot length. Okay, and x plus plus. Okay, and then we're just going to say if the letters at x is equal to an L, is equal to an L, then our L count plus plus, right? Else if letters at x is equal to an M, then we are going to say M count plus plus. Okay, and at the end, that should tell us what our L count is and what our M count is. So I'm going to do the test here. So L count and M count. Right, and we're just going to see what the total counts are. and it should count. So 6, 5, is that correct? Yep, that's correct. Now, if I know the size, then I can actually also calculate how many of the S's there were. So that's why I don't need to do the counting of the S's. Okay, so the first thing we're going to do now is we're going to say we know our section 1. Our section 1 is the first section where the L's belong. And that goes from 0 to the L count. So if the L is 6, then this would be 0, 1, 2, or so look, we go 1, 2, 3, 4, 5, and 6. So up to here. Okay, so this is the L section. This is where the L's should be. But if you look at the indexes, they go from 0, 1, 2, 3, 4, 5. And so what we need, or what we can know, is that from index 0 to 5 is where all the L's should be. So what I'm going to do next is I am going to go in and just count that section. X is equal to 0. X is less than L count. Now it's not less than or equal to, it's just less than because we're going from 0 to less than that. Okay, so in this case we have 6 L's, but we're going from 0 to 5. L count and then X plus plus. All right, now what I want to do is I want to count how many M's there are and how many S's there are. So I'm going to say int section 1 M's, okay, is equal to 0. And section 1 L's, okay, also equal to 0. All right. Okay, so I'm going to say if the letters at X is equal to an M, then section 1 M's plus plus. Else if letters at X is equal to an L or an S, then section 1 L's plus plus. Okay, now at this point I will know exactly how many M's and L's are in section 1. Okay, I've got to repeat that now for section 2. Okay, well, here's the thing. Where does section 2 start? Okay, so we're going to basically do the same type of thing. So we're going to say int section 2. Now in section 2 we don't care about the M's, we only care about the L's and S's. So we're going to say L's is equal to 0 and section 2 M's is actually S's. We'll just say S's is equal to 0. All right, so we got L's and S's. Okay, so section 2 L's is 0, section 2 S, yeah, that sounds right. Okay, so then we're going to say for int X is equal to, well, where do we start? We don't start at 0. Well, section 2, if you look here, is going to start at our L count, right? Because remember our L count here was 6, and we're going to go 0, 1, 2, 3, 4, 5, 6. But remember from before that the indexes were from 0 to 5 for the section for the L's. So we're going to go from 6. Okay. Now how far up do we go? Well, if there's 5 M's, then we're going to go so from 6, 7, 8, 9, 10. So we need to have this section. All right, so there's the 6 L's, 1, 2, 3, 4, 5, 6, and then the 5 M's, 1, 2, 3, 4, 5. And if you add that up, that's going to be 11, right? And so what that will do is that this is the 11th letter, but it means that we have to stop before 11. So we're going to just check up to 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our limit for the for loop is going to be our L count plus our M count. Okay, so we're going to start at the int X is equal to 0, or L count. Okay, the limit will be X is less than L count plus M count, and our X will just go up by 1 each time. Okay, then we're going to say if the letters at X is equal to L, then our section 2 L's is plus plus, so it goes up by 1. Okay, and else if letters at X is equal to S, then our section 2 S's is plus plus as well. All right, and there we go. At this point now, we know how many L's are in how many misplaced things are in section 1, and we know how many misplaced things are in section 2. Okay, next part. We're going to do the same thing now for section 3. So int section 3. Now in section 3, we don't care about the S's, we only care about the L's and M's. So we're going to say L's is equal to 0. Section 3 M's is equal to 0. Okay, and I feel like I made a mistake here. Yes, in section 1, this should be S's, because I'm an idiot. Okay, so S's, section 1 S's. So in section 1, we only care about M's and S's, so if it's an M, it goes M. If it's an S, we go S's. All right, there we go. Section 2, we only care about L's and S's, so it's L's and L's, S's and S's. Okay, just making sure I don't mess this up. Okay, so for int x is equal to, now where do we go? Well, last time we ended at L count plus M count, so that's where we're going to begin this time. Okay, so we ended right before this. Okay, so we're going to go up to that point. Now, x is less than the letters dot length and x plus plus. Okay, and basically we're going to say the same thing as before. Letters at x is equal to, if letters at x is equal to L, then our section 3 L's plus plus, and else if letters at x is equal to and M, then section 3 M's plus plus. Whew, okay. All this just to count L's, S's, and M's. Okay, now we've got our counts. So what we can do next is we can say looking at direct swaps. Okay, so all of this stuff is here is just counting out of place letters. Okay, now here what we can do is we can considering direct swaps. Now direct swaps are going to be the best. So what we're going to do is we're going to say int swaps is equal to 0. Okay, so because right now we haven't done any swaps. Now if we look, let's just consider section 1 swapping to section 3. Okay, so that's if there's any S's in the L section and there's L's in the S section, then we can swap them over. Okay, so what we're going to do is we're going to say if. So if section 1 L's or section 1 S's, we didn't care about that. If section 1 S's is not equal to 0 and section 3 L's is not equal to 0. Okay, that means that we have L's in section 3 and we have S's in section 1. That means it's possible to actually do some swapping here. Okay, so what we can do is we can then say, look, now here's the ideal situation. If section 1 S's is equal to section 3 L's, okay, that would mean that we could swap all of the S's in section 1 with all of the L's in section 3. Okay, so then what would happen? Well, that would mean that in section 1, the S's would become 0. It also means that in section 3, the L's would also become 0. And it would also mean that we would need a certain number of swaps. Now, if we add the swaps here, so what I want to do is I want to say, well, how many swaps did we need? Okay, so we're going to say swaps plus equals, well, it was whatever section 3 L's was. Okay, or you can say section 1 S's because it's going to be the same number. Okay, but because we already set them to 0 here, this is just going to add 0. So we have to actually just push this up and move this command up to here so that we add it on before we set them down to 0. Okay, now what if this is not the ideal situation? Okay, so we're going to say else if. Okay, so what if what if there's fewer L's? Okay, so what if, or let's say the S's is less than the L's. Okay, well, if you have fewer S's in the section 1 and more L's in section 3, the most you can transfer is just the S's. So you can move all the S's over, like swap all the S's, but you wouldn't be able to swap all the L's. So what we can do here is we can say that the swaps plus equals the section 1 S's. Okay, because we would be able to swap all of those S's over to the other section for all of those L's. Now, the section 3 L's, right, would take away section 1 S's. All right, so if there was, like, say, for instance, let's say there was 2 S's in section 1 and 5 L's in section 3. Well, what that would mean is that I can move both of these over. Now there would be 0, so the section 1 S's would become 0, okay? But the section 3 L's would only go down by the 2, right? Like it would only go, so the L's in section 3 would only go down by however many S's we could actually swap over. Okay, I hope that's a good enough explanation. So now, if they're not equal, so here I checked that they're not 0. If they're not equal and S's is not greater or less than, then it must be, in this case, that we have more L's or more S's than L's. Okay, so in this case, we're going to say swap plus equals section 3 L's. Okay, and then section 1 S's minus equals the section 3 L's. All right. So what we're saying here is that there are more S's than L's. So then you can take away all those L's from the S's, right? And then the L's would become 0. So we would say section 3 L's would become 0. All right. And that should be it for direct swaps from section 1 to 3. Okay, we got to do the same thing now, but we got to do it from 1 and 2, okay, between section 1 swapping from 1 to 2. Okay, so we're going to do the same thing now, but we're going to do section 1 swapping with 1 and 2. Okay, so section 1 swapping to 1 and 2. So in this case, I really only care about section 1's M's, okay, and section 2's L's. So that's what I'm considering here. Okay. Now in this case, we're going to do the exact same thing. So we're going to say, here's our ideal case. If section 1's M's is equal to section 2's L's, then we can just swap them all. So section swaps plus equals section 2's L's, and then set them both to 0, and done like dinner. Okay, whew. Else if, now what if section 1 M's is less than, if section 1's M's is less than section 2's L's. Okay, so there are more L's in section 2 than there are M's in section 1. Okay, so what I'm going to do then is I'm going to say, so you can only ever swap the least amount. So swaps plus equals section 1 M's. Okay, and then we're going to say the section 2 L's minus equals section 1 M's. And our section 1 M's would all have moved away, so they now equal to 0. Okay, and then finally we can say else. Okay, now the only other possibility is that if there's not equal and there's not fewer M's than L's, then there must be fewer L's than M's. So we would say section 1 M's is greater than, oh, actually we don't need that because it's just an else. Okay, so there are more M's. Okay, so remember, we can only ever swap the least amount, the smaller amount. So section 2 L's is the smaller amount. Then section 1 M's is minus equals to section 2Ls, and our section 2Ls would be equal to 0 because we would have swapped them all away. All right, so that's swapping between section 1 and section 3, then section 1 and section 2. Now we have to do this for all the different sections, but it seems like this is a lot of work. Okay, but the next thing we're going to do is we're going to swap for section 3, so, or section 2. Okay. Okay, so we're going to say section 2. Now, we don't need to swap section 2 with section 1 because we already did that right up here. All right, so we can just go section 2 with section 3. Okay, now the fact is, like, then when we get to section 3, we have already done 2 with 3. We're doing it right now. And we have also done 2 with 1 or 3 with 1 over here. So this is actually the last section we need to write. All right, so we're going to say if section 2 m's does not equal to 0 and section 3L, actually, what are we trying to swap here? So m's with s's. So section 2, we don't care about the m's. So section 2 s's is not 0 and section 3 m's does not equal to 0, right? Because I'm swapping the s's from section 2 with the m's in section 3. Okay. Okay, so I have s's in section 2 and I have m's in section 3. Okay, so again, our ideal case is if the section 2 s's is equal to the section 3 m's. If they are equal, then what I can say is that the swaps, they can all swap over, so swaps plus equals section 2 s's, okay, section 2 s's is equal to 0, and section 3's m's also is equal to 0. All right, I'm just going to quickly check my scopes here. I feel like it's good, but it never hurts to check intermittently, make sure everything. Oh, see here. I knew it. I felt like something had gone wrong here. Okay. Okay, looks good. Okay, else if. Okay, so now that's if they're not the same. So if I can say section 2, I care about the s's. If the s's is less than section 3's m's, and okay, so if section 2's s's is less than section 3's m's, that means that the most I can swap is just the s's. So I would say swaps plus equals section 2 s's, section 3's m's minus equals sections 2's s's, and that would mean all the s's are gone from section 2, so just set it to be 0. Whew, okay, last one. Okay, so we can say else. Now, we're just going to say swaps plus equals. Now, that we always add the lower one, and in this case, it has to be section 3m's. So section 3m's, section 2s's has to subtract the section 3m's. Okay, and the section, let's see, so in this case, section 3m's is the least one. So section 3m's is equal to 0. All right, whew. Okay, let's just do some test code here and just see out the swaps. Swap count. Okay, so we're just going to output the swap counts at this point. Now, for our particular input, right, so what would happen here? So 1, 2, 3, 4, 5, 6. So here we've got, okay, so let's just break it up here. So that's our first section. So the 6 L's, we have 5 M's, 1, 2, 3, 4, 5. Okay, so it should look like that. All right, so how many L's and M's can we swap out here? So we have 2 M's, 2 L's. So we could actually do 2 swaps here, right? These 2 M's for these 2 L's. Okay, how many S's? We have 2 S's, 2, oh, it works so there's 2 more. So our swap count should be 4. And then from here, how many S's can we swap out? Oh, 2 more for these 2. So it should be 6. So if we run it like this, we should have, our output should be 6. Okay, so here's hoping. There we go. Swap count is 6. Okay, now at the end, okay, we could have we got to check for those triplets. All right. So then what we can do though is say, well, we can go through and start counting triplets or whatever, but you actually don't have to. What we can do is we can say int, let's say leftovers. Okay, so the leftovers is going to be all of our different sections. So section plus 1 M's plus the section 1 S's plus the section 2 L's plus the section 2 S's plus the section 3 L's plus the section 3 M's. All right, so that should be 6 terms, 1, 2, 3, 4, 5, 6, and they are all different terms. Yep. Okay, so that's our leftovers. Okay, now it's not possible for there to be a number of leftovers that is not divisible by 3. All right, because if there was, then that would mean that you would have to be able to, that you could have done like another swap somehow. It has to be some multiple of 3, right? So what we can do is we could say, well, if you just take the leftovers, okay, and you could say something like this. So whatever this leftover amount is, you could divide by 3 to find out how many triplets there are, right? So if this was 9, if there was 9 of them, that would mean that there's 3 sets of triplets, or if there's 12 of them, that means there's 4 sets of triplets. All right, and as I said at the very beginning, you need 2 swaps per triplet, so you just say times 2. All right, so that's going to be that. Now, if this is going to represent the number of swaps we have to finish swapping the leftover bits. So we actually don't even need this leftover variables. We can just say swaps plus equals that amount. Okay, and then at the end, we can just say cout swaps, and that should be it. Okay, so let's take away our test code. Okay, so actually we can just put in the sample code from the program, so LLSLM, and this should say 2. Okay, fingers crossed, 2. Okay, and if the other one was LMMMS, and this should be 0 because it's already in order. 0, good. All right, and I don't think they gave you anything else. Okay, well, let's throw this into the grader and see how we do. Okay, so I've thrown this into the grader. We'll submit, and oh no, that's not going to work because we have this hard-coded. Damn, I got to go fix that. Okay, so we're just, I'm such an idiot. Okay, we got to just put this C in back in there. Okay, so we will just recompile this and put it back in the grader. Okay, and submit. So we're gonna, this is the new one. Yeah, there we go. Okay, looks good, and refresh, see how we do. So far so good. It's nice to see correct ones. Okay, there we go. So far got 9 points in the question, 13 points, and 15 points. There you go. That's how you do CCC Junior 4 from 2021. Anyway, stay tuned, and we will work on Junior 5 coming up.